Now, till now we had seen H parameter model, and that is what we used for the BJT small signal AC analysis, right? But it has a limitation. H parameter model has a limitation, and people explained something called hybrid pi model. Okay, maybe if you take H parameter model, BJT H parameter model, and hybrid pi model, BJT hybrid pi model. Remember, at low frequencies both are same. At low frequencies both are same. What is the reason to go from a different model, from H parameter model to a different model? Whatever we had seen, like whatever we calculated all AC parameters for different configurations using H parameter model, which we got from two-port network analysis, right? Why it is having a limitation? Let me explain, right? Therefore, what is H parameter model? Therefore, if you consider your transistor, just listen, if you consider a transistor, this is collector, emitter, and then base, right? Then the equivalent circuit what we got, I'm taking exact model only. This is what is our exact model. Just now we had seen from both quantitative analysis as well as qualitative analysis we are able to correct, right? Correlate, sorry. This is base and then emitter, right? We got to know that this is nothing but HIE, and this is what is HRE into VCE, and this is HFE into IB, and this is 1 by HOE, right? And this is what is our equivalent circuit. This is collector and then emitter. Right? Now, this is nothing but our input voltage VBE. This is VBE, and this is your IB. Now this is VCE, and this is your IC, right? Therefore, the relation between VBE to IB, the relation between VCE to IC, and internally all are described with your H parameter model, and everything is matched with respect to the operation. Fine. Then what is the limitation of this? Okay. Let me tell you, when you use your circuit in amplifier configuration, right? Let us say, if I use like common emitter, don't write, okay? If you take common emitter amplifier, what do you mean by common emitter amplifier? Same thing, we are going to use this transistor for amplification purpose, right? Therefore, let us say only AC circuit. I am speaking about only AC analysis or AC circuit, okay? Then this is what is our configuration. Emitter is common, and this is what is your load. This is what is my load, and this is your output voltage, and this is what is my input voltage, right? Now this is what is the black box. Now the BJT, right? Whatever BJT we have, this is what is collector, emitter, and base. Okay. Now only AC circuit. Okay. Input is applied and then output is taken from the load. Fine. Then now this black box can be replaced with H parameter model, which we already did, and we calculated all AC parameters. I am repeating the same sentence again and again. If I repeat again and again, that will be going into our brains. Okay. Therefore, now this black box is replaced with H parameter model, whatever we had seen. Now, therefore, this is what is my input AC signal, and this is what is my output AC signal. Let us say this is what is my audio amplifier. Therefore, I am giving the signal at the input, I am getting the output here. Then we have whatever voltage gain we got, yes, everything is satisfied. But remember, when we do frequency response analysis, that we are going to do later after completing DC analysis, because I told that AC analysis is done. Now, after this we are going to start DC analysis. After completing DC analysis, then AC analysis, we are going to combine, and I am going to give you the final circuit. For that final circuit, I am going to give the frequency response analysis of that amplifier. Then this will come into picture. That is the reason I'm explaining. What will come into picture? The limitation will come into picture. What does it mean? What do you mean by frequency response analysis? Let us say my x-axis is the frequency of the input signal, whatever I'm giving here, and I want to know V0 by Vi. That is nothing but voltage gain. AV is equal to V0 by Vi. Only magnitude I'm taking. If I take, right? Then tell me, how will we get, if you take only AC part, right? Now, whatever gain we calculated, right? What is the gain we calculated? If you say, this is what your voltage gain we calculated, which is nothing but AI into RL divided by RI. And what is AI? I'm using exact model, right? If you take exact model or if you take simplified model, anything is fine. Even if you take simplified model, you will get, what is AI? AI is equal to minus HFE into RL divided by HIE. This is what is our simplified model, right? If I neglect base width modulation, and this is what is your simplified model, voltage gain minus HFE into RL divided by HIE, right? Now, this is what is the voltage gain, and it is independent of frequency basically. But if you increase your input signal frequency, then your output signal will be attenuated because of some reason. Your output signal is attenuated at high frequency, and whatever gain, which is what is calculated using H parameter model, right, is not true. But according to H parameter model, irrespective of input signal frequency and then output signal frequency, the gain is simply minus HFE into RL divided by HIE. But practically, your gain will be falling at high frequency. Your gain will be falling at very high frequency. The gain will be reducing. Why gain will reduce? That part I'll explain. But let me explain a little bit here. Why gain will reduce? Because this is nothing but a PN junction diode. This is a PN junction diode, right? This is nothing but an emitter junction, JE. And we have another PN junction diode. This is nothing but our JC, collector junction, right? Now tell me, if JE is in forward bias, it is associated with some capacitance called, this you study from your VZT. When PN junction diode is under forward bias, that is associated with diffusion capacitance CD. It will have diffusion capacitance CD. When PN junction diode is in reverse bias, it is associated with transition capacitance CT, right? These two capacitances are not accounted, are not considered under H parameter model. Because those capacitances are not considered, are not modeled in H parameter model, right? Always we get gain which is minus HFE into RL divided by HIE. The gain is not changing with respect to input signal frequency. But if you consider the effect of capacitances, right? Tell me, for low frequency or mid range of frequency, I can take this capacitor almost what? Open circuit, because what is your capacitance reactance? We know that Xc is equal to magnitude 1 by omega C, right? C is very small. Then for low values of omega, for omega mid range of frequencies, for low values of omega, right? Tell me, what is your mod Xc? If omega is very small, 1 by very small, it is very high. Therefore, you can take it as infinity only, approximately. Means, what does it mean? Open, open. Then there is no effect of capacitance. It is simply transistor, the low frequency transistor model, which is matching to H parameter model. Therefore, whatever gain we calculated, assuming this is what your model, then we got minus HFE into RL divided by HIE. Satisfied. There is no issue at all. But coming back to very high frequency, as the frequency of your input signal is increasing, then you know what will happen. Therefore, tell me, whatever input we are applying here, that input is translated from base to output collector current, that is through transistor. But now tell me, if the capacitor CT and then CD are coming into picture, let us say at very high frequency, let us say infinity frequency, right? Then what about this capacitor? At infinity frequency, what is this? 1 by infinity is 0, right? This is short circuit. Therefore, now tell me, the input what you are applying at the base, now it is short circuit. What does it mean? Your output is equal to input because of the capacitor what you have, that is due to transition capacitance of reverse bias PN junction. And what about this capacitor? Short circuit. Then emitter at the 0, ground. Your output is 0 because of this capacitor. Your output is equal to input because of this capacitor. Therefore, there are two input sources trying to drive your V0, then your output will be in between 0 to Vi. Whatever may be, your V0 will be less than Vi or less than or equal to Vi. Means your gain will be less than or equal to 1. What does it mean? Whatever gain we calculated, now that is no more valid at very high frequency because of internal capacitances what we have related to BJT. Therefore, whatever H parameter model we considered, right, that is no more valid at very high frequency because it did model the internal capacitances. I hope everyone understood. That is the reason why people developed one more model including internal capacitances, which are nothing but CD and then CT. People call it as C pi and then C mu, anything. CD or CD is nothing but diffusion capacitance, CT is nothing but transmission capacitance. Now we need to account those capacitances and then draw another equivalent circuit. That is what is called BJT hybrid pi model. That is what is used to calculate the frequency response of your BJT amplifier, and then from which people calculated what is the bandwidth of your amplifier. Everybody understood, right? The limitation of H parameter model is it cannot explain high frequency response. Therefore, you can write down it failed. What is the limitation? Therefore, limitation of your H parameter model is nothing but H parameter model, BJT H parameter model failed to explain high frequency response analysis. Failed to explain high frequency response. BJT H parameter model failed to explain high frequency response. That is what is enough. Okay. It neglected basically, or it didn't consider. The model is not considered. Therefore, it is not accurate. Right? Therefore, it failed to explain high frequency response. Therefore, it is not accurate. Therefore, not accurate. The model is not accurate at high frequency. Now, BJT hybrid model has come into picture to explain the high frequency response analysis, considering the BJT internal capacitances. That's it. But you know, maybe you can say we can add capacitance directly here only for H parameter model, then no need to go for anything. Yes, I agree. But what people gave, because H parameter model, it was going on for all the circuits. But remember, later on in between, in 1960s, I can say in the out of 1970s, people started using MOSFET also. Then we got MOSFET equivalent circuit, AC equivalent circuit, right? Then people did not go with H parameter model. People, I can say, that is a kind of Y parameter model, that is what is considered. But what it may be, based on the operation of your MOSFET, we got something like, because your output MOSFET output current, which is the drain current, is depending on input gate to source voltage, not input gate current. Because what is input gate current? I already explained. Gate current is equal to 0, but the input gate to source voltage is the one which is what is controlling your output current. Therefore, input voltage to output current relation, voltage control current source. But in the case of BJT, your output current is controlled by input current. Therefore, it is current control current source action. That is what is this, right? Therefore, people call BJT as current control current source. MOSFET is called as voltage control current source. But remember, can't I call your BJT also voltage controlled current source? Yes, people already named. Remember, it is current control current source. But can't I treat your BJT, or can't I model your BJT as voltage control current source? How? Let me explain. Your output current IC is controlled by whom? Your output current IC is controlled by IB. And your IB is controlled by whom? Your IB is controlled by VBE. Means VBE is controlling IB, IB is controlling IC. Therefore, can I say your IC is controlled by VBE? That is nothing but what? Voltage is the one which is controlling your output current IC. Right? Am I correct or not? Are you following me? Yes, therefore your output current is controlled by input voltage indirectly, but directly output current is controlled by input base current, but input base current is controlled by VBE. Therefore indirectly I can say your output current is controlled by input voltage. Therefore I can call BJT also as voltage controlled current source, similar to your MOSFET or JFET. In the case of MOSFET there is no input current, therefore there is nothing called current controlled current source, right? But that also you can call this current control current source. I don't want to confuse you. Don't go in that way. I am speaking with respect to the device. Therefore, I can call your BJT as current control current source, or I can call BJT as voltage control current source. Right? Then which one is correct? Because primarily your output current is controlled by input current. That is primary relation. Then the secondary relation is output current is controlled by input voltage. People always call it as current control current source. But I can model like voltage control current source also. That is what is taken. Because in the case of MOSFET, that is voltage control current source. Therefore, to mimic or to map or to have the relation or to have the comparison or to have similar models for MOSFET and then BJT, people took BJT also voltage control current source in the case of hybrid pi model along with the BJT internal capacitances to explain high frequency response. That's it. That's why it is important for high frequency response analysis, right? I can add directly the capacitances here, therefore it will explain high frequency response also, but people did not do that. People just changed it into voltage control current source action and internal capacitance also. Just listen how to do it. Now, what is your input? My input is VBE. Input is VBE. Input is VBE and then input current is IB. Okay. Now can I say therefore based on the operation you can say let me call this as RBE, base to emitter, because this is base and this is what is emitter. Therefore your IB is equal to VBE by RBG in this whatever I am representing, but I am going to see. Therefore tell me, but we have something. What is that? Not only RBG we have between base and emitter we have something. What is that? Between base and emitter we have diffusion capacitance. Okay, we need to account capacitor also, then only it will explain high frequency response. Therefore we need to add the input capacitor. Therefore this is what is our CD, the diffusion capacitance. Okay, fine. Therefore input side and input capacitor is explained. Now coming to output side. What is your output side? Output is nothing but your collector to emitter, and emitter is common. Let us say this is common emitter configuration, therefore VCE, and now this is what is your IC, right? Therefore tell me your IC, whatever you have, right? Whatever your IC. Now I don't want to write IC is equal to HFE into IB or something into IB. I want to write IC in terms of VBE because I want voltage control current source action. I can model in that way, right? Now if I model in that way, therefore now this is what is depending on what? Now this is what is depending on something into VBE. Therefore what is that something? Therefore this is nothing but something into VBE. That something is nothing but GM into VBE. Why that is GM? Because I want IC this is collector, emitter, this is VCE, and this is IC, right? I want IC, therefore what is IC? Therefore IC is equal to something into VBE. I want output current to be depending on input voltage, then only voltage control current source, right? Therefore, this is what is voltage control current source. But here if you see, IC is equal to HFE, or this is what is, it is proportional to HFE into IB. Therefore, this is nothing but current control current source, right? Therefore, similarly, your IC is also proportional to something into VBE. When I say proportional to something into VBE, therefore that something is nothing but GM, because this is equal IC by VBE, output current by input voltage, conductance, trans conductance. Therefore, that is what is GM of your BJT. Therefore, IC is equal GM into VBE, but we have base width modulation. Because of base width modulation, what you have? Because of base width modulation, we have, let us say, RCE. In the case of H parameter model, you can correlate to 1 by HOE. But remember, in the case of base width modulation, when you have this, we have to have some dependence on, right, IB. Your IB also should be depending on the IC, right? That also we have to add, and that is one thing. And we have reverse bias PN junction diode between collector to base, right? Then it is having some, because of the reverse bias PN junction diode, we have base width modulation. What is base width modulation? When VCE is increased, keeping VBE constant, your VBC or VCB is changing, then that is what is changing your base width, and that is what is changing the base current, that is what is changing your collector current. That is what we have seen. That's why HRE and then 1 by HOE, they are added. Now to account HRE and 1 by HOE is already added, which is RCE. To account this HRE VC effect and accounting the transmission capacitance which is CT between base and collector, then because this is under reverse bias, that resistance is represented. Therefore, now this is what is the resistance which is what is represented, and this is what you can say RBC. Indirectly, this is what is explaining the K into VCE or HRE into VCE, because now if you calculate IB, your IB is not only function of VBE, your IB is also function of VCE because of the bridge which is what is there in between collector to base. And we have capacitance between base to collector, that is reverse bias capacitance CT. Therefore, CT is added here. This is nothing but your CT, the transmission capacitance. Therefore, now this is what is your BJT hybrid pi model. Why it is called pi model? Looks like it is pi only. Why? You take this one part, one part, one part. It is like this, you know. This input is having something, then we have another branch, and we have another branch, right? It is like pi only, right? And this is ground, what it may be. Therefore, this is what your input and this is what your output, right? This is your base, and this is emitter, and this is collector, this is emitter. Therefore, it is like pi structure. Therefore, but having capacitor, resistor, transconductance, etc. Therefore, hybrid parameters, but it's like pi. Therefore, hybrid pi model of your BJT. Okay, that is what it is. But now remember, now this model is having the internal capacitance CD and then CT. Now, if you calculate using this model, for example, this is what your CE amplifier. Now, if you take out this black box, the model, instead of H parameter model, now if you use hybrid pi model, use that hybrid pi model, then get the gain. Now the gain is not depending on only the internal H parameters which are fixed, right? Now it will depend on your capacitance also. Then we know that the capacitance reactance is depending on frequency. Therefore, your gain will be function of frequency. That is what people used with respect to frequency. Then we got gain which is depending on frequency. Okay. You take this. Then let's try to correlate between H parameter model to hybrid pi model. Remember, at low frequency, both will give you same answer. Both will give you same answer. Not will give you, should give same answer. Because at low frequency, we can neglect the effect of CD. That's what I told, right? At low frequency, the XC reactance is infinity, means open, open. Then open, open. Then output to input relation. However you represent internal, the BJT internal circuit, but ultimately to the output to input, both should give the same result or same voltage gain. That is very, very, very important. But at very high frequency, this is giving accurate gain, but it is not giving accurate gain because it did not consider BJT internal capacitances. Okay, that is very important. Therefore, take this model, but both are familiar. But whatever we are solving till now, and we solved till now, remember, using H parameter model. Therefore, in the examination, they are asking using H parameter model because everything we are asking for low frequency, not at very high frequency. Okay.
At low frequency, we can neglect the effect of CD and CT. Then both should be same. This is what is the constant parameter, HFE. That is gain, current gain, but here transconductance gain of your BJT. Now we should get the relation between GM to H parameters. That is what is nothing but correlating. Because in the examination, they are not giving, I told right, whatever problems you are solving and you are getting voltage gain in terms of H parameters, if H parameters are known to you, we can substitute and then we can get voltage gain. But sometimes remember, H parameters are not given. Then GM will be given. Then we need to correlate the relation between H parameters to GM. Then once you know GM to H parameters, then if GM is given, yes, we can calculate voltage gain. Okay. Therefore, we should know the relation between H parameter model to hybrid pi model. If you know that, problems are over. Okay. That's fine. That is what I'll explain. What is the relation between GM to H parameter models? I don't have space here, otherwise I would have continued. Anyway, that we can write after this. See, we are going one by one. Okay, that is important. Incrementally we have to learn. Just a minute. Continue. I will give for one more minute. I hope this is done. Now, write down relation between, next subheading, relation between GM to H parameters. Therefore, now we are trying to correlate the transconductors to your H parameters. Okay, write down relation between GM to H parameters. Okay, done. Let me erase all these portions, but I want these two equivalent circuits. But you have to write just below these two. I don't know whether you are writing in column wise, but it's better if you write column wise always if you want to compare, right? Because you are trying to compare. Okay. So out of total syllabus, two topics which take more time. Number one, BJT small signal AC analysis. I think so many sessions we are continuing to complete BJT small signal AC analysis. We are about to close this topic and then go to DC analysis. Then one more topic, op-amp. Op-amp also takes more time. Then these two topics will take more and more time, but remaining topics we can wind up very fast because majority of the concepts will be covered under BJT and majority of the applications of your normal amplifier and the circuits will be covered under op-amp. Okay. Now, to get the relation between GM to H parameters, right? Now we need to equate with respect to external components, external variables like VBA, IB, VCE, IC. Okay, don't write. Tell me what is your IC? We know that H parameter model equation are from equivalent circuit. What is your IC? Now I told, right? At low frequencies, both the models should be same. At low frequencies, both the models should be same. At high frequencies, because this is not accurate, now this is what we will take. But now I am trying to correlate at low frequencies to say that both are same, right? Therefore, maybe to do not have any confusion, I can say at low frequencies. At low frequencies. Therefore, I can neglect the CD-CT. At low frequencies, both are same, or both should be same. Okay. Now, tell me what is your IC? We know that H parameter model, right? We know that what is IC? IC is equal to, tell me, HFE into IB plus, follow me. Okay. Follow me in the sense, don't write, just listen. Follow me with respect to the vocal support. Therefore, HFE into IB plus HOE into VCE. This is what is your IC equation, right? Now, tell me what is IC here according to this, right? Therefore, again at low frequencies, right? Therefore, what is your IC? Maybe that's fine. Now, okay, just now when VCE is equal to 0, when VCE is equal to 0, tell me when VCE is equal to 0, what does it mean? Short this, then 1 by HOE is coming in parallel to it, right? Then what is your IC? Therefore, what is your IC? IC is equal to make it effective, because I don't have space here. Okay. To explain effectively what I am doing, first of all, H parameter equations, right? At low frequency, tell me both the equations. VBE is equal to HIE into IB plus HRE into VCE. Similarly, what is your IC? IC is equal to HFE into IB plus HOE into VCE. Right? Now, tell me what is HIE when VCE is equal to 0, right? When VCE is equal to 0. Tell me what is when VCE is equal to 0, right? What is HIE? HIE is equal to VBE divided by IB. Then what is HFE? HFE is equal to IC divided by IB. But remember, these are all true when VC is equal to 0. Right? That is fine. Now, coming to hybrid pi model, right? Coming to hybrid pi model, again at low frequencies. Okay? There only, hybrid pi model at low frequencies. At low frequencies. You have to write this under VZT, you have to write this under hybrid pi model, okay? At low frequencies, when VC is equal to 0, directly I can write, right? When VCE is equal to 0. Tell me when VCE is equal to 0, this is short circuit, right? Then tell me what your IC. Your IC will be what? Because short circuit in parallel to a resistor. Short circuit only, therefore then what is your IC? This is what your IC. Can I say that? And you may say when this is short circuit, this node will be connected to ground, and then CT also will be connected to ground. Then this RBC and then CT will come in parallel to RBE, CD, and then all those things. But now this current source is coming in short circuit. Therefore, what is the current which is what is flowing through it? Because current always flows through short circuit. Therefore, that is nothing but GM into IBE. Therefore, what is your IC? IC is equal to GM into VBE. Therefore, what is GM? GM is equal to IC by VBE. Therefore, we know, right, what is input impedance? Input voltage by input current when VC is equal to 0. What is your current gain? Output current by input current when VC is equal to 0. That is using H parameter model. Similarly, when VC is equal to 0, What is our GM? Output current divided by input voltage, right? That is what is using hybrid pi model. Now I want to get the relation between GM to H parameters. Can we get it? Right? Now, let's see. Can I write this as, what is the reason to have? Because, very simple. This is nothing but what? Voltage control current source. Right? What is this? Your output current is controlled by input voltage. Your output current is controlled by input voltage. That's why we used GM. But in the case of H parameter model, your output current is controlled by input current is controlled by input voltage. What I do, can I write this as IC divided by IB? Because we know that your IC is controlled by IB and IB is controlled by VBE. Can I write like this qualitatively? But quantitatively also both are same. Because IB will be cancelled, then you will get IC by VBE. Therefore, this is nothing but GM, right? But if you take hybrid pi model, we don't have anything IC to IB and then IB to VBE. Directly IC to VBE, that's a GM. But I am trying to correlate hybrid pi model to H parameter model. That's why I am writing in terms of IC to IB and then IB to VBE. But remember, that is true only when VC is equal to 0. Therefore, tell me, when VCE is equal to 0, what is IC by IB? IC by IB, that is nothing but what? HFE. Therefore, what is GM? GM is equal to, remember, this is what is the definition. Okay, that's fine. This is what is star. I'll use it later. Therefore, what is GM? GM is equal to IC by IB. That is nothing but HFE into IB by VBE when VC is equal to 0. When VC is equal to 0, what is IB by VBE? 1 by HIE, right? Therefore, this is nothing but 1 by HIE, which is nothing but GM is equal to, it is HFE divided by HIE. This is what is your GM, and this is what is the relation between hybrid pi model transconductance to BZ H parameter model H parameters. Therefore, GM is equal to HFE divided by HIE. Let us say in the examination, right, common emitter amplifier is given, but H parameters are not given. GM is given, then can't you calculate voltage gain? Therefore, at low frequencies, right, at low frequencies, what is our AV? AV is equal to minus HFE into RL divided by HIE. But what is HFE divided by HIE? Which is minus GM into RL. Therefore, you can use either these two. If H parameters are given, you can use it. If GM is given, you can use it. Anything is fine. Because there are problems associated to GM also, then we should get it. Understood? Okay, fine. But there is another way. Sometimes GM won't be given directly. We need to calculate what is the GM indirectly. Then that is what we need to use. And then that is those indirect values should be taken to calculate GM. That GM should be used. Therefore, you will get voltage gain. Let's see what is the GM from the definition. From the definition, I am going to explain what is the GM. Okay, that we will get it. Take it. With that, I can say H parameter model to hybrid pi model correlation is done. See, all these things are important with respect to knowledge wise. At the same time, problem solving also. Because directly we will not give H parameters in the examination. And if directly or indirectly GM is known to you, then we can calculate voltage gain even though you don't know H parameters. Okay, fine. Remember, we have to write that flow frequency H parameter equations when Vc is equal to 0. That part we have to write just below the H parameter model of BJT, and this portion you have to write below this, and this is what you can write common below to those two what you have written, continuation part, because this is what is valid for both. And this is the equation which we got from H parameter model, and this is the equation which we got from hybrid pi model. Okay. I think this is enough for the session. Then, because if I want to continue, maybe in the next session, what I will explain. Now we got to know the relation between H parameters to GM. Now I want to define what is GM. Definition is already there. From this definition, I want to derive the GM value with respect to BJT, DC equation, or whatever it may be. Okay, because that's what I told. Sometimes GM also won't be given directly, which we need to calculate, right, from the circuit. How to calculate that? What is the relation between the DC parameter to the AC GM? That is what I will explain. With that, I can say the GM part is over, or hybrid pi model is also over. Okay.